Hello everybody and welcome to the Kreatryx YouTube channel. I welcome you all in a fresh session of analog electronics. And my dear friends, when I say we are going to learn analog electronics from the very basic, I mean it. We will be learning from the very basic level to the very advanced level along with a lots and lots of questions. So before we do that, let me first introduce myself for my friend who is meeting me for the first time. My dear friends, my name is Ankit Goyal. I got AIR1 twice in GATE in 2014 and 2018. I was awarded the President of India Gold Medal in the year 2013 when I graduated from IIT Indore. Till date, I have trained more than 1 lakh students in the online and the offline classes and presently working as a director at Unacademy for GATE department. But my dear friends, the reason behind this series is because of the huge demand of analog electronics and the belief that whenever you ask for anything, we are there to deliver. Yes, my dear friends, we are here for you. We are here delivering for you. And when we say it, we will support you to the very fullest level. And this series will help you crack GATE with the top rank. It will enable ECE student to get 12 out of 12 and 5 out of 5 for electrical students. So my dear friends, if you want to learn with us live, then you can join Unacademy using the code Ankit ESE to get an immediate 10% discount. And not only, my dear friend, 10% discount, it also brings you under my guidance so that I can help you do something that I have done. I can at least take you near to this goal. Okay. So if you also dream the same thing, then join me in this journey on Unacademy subscription using the code Ankit ESE. Now, my dear friend, if you like the content that I deliver, you can watch more of my free videos on this URL, tinyurl.com/AnkitESE. Here you will find all my videos arranged subject-wise, chapter-wise, and you will find great content for free. And you are definitely going to love it. You are definitely going to enjoy. It not only includes conceptual videos, but it also includes problem-solving sessions. So just visit this once and you will fall in love with this URL. Don't forget it. It is a lifeline for you. And if you love the content that we are delivering on YouTube, we have created the first ever video book for you guys, where you will find all the videos along with all the notes that we provide arranged subject wise, chapter wise. So now, my dear friends, your dreams are no longer dreams. They are becoming a reality because you are getting a top quality course, well arranged, well structured, and that too for free. So what can be better than that? What can be better than that? Nothing, my dear friends. So we have empowered the dreams of those who earlier used to think that only the person with a huge amount of money can crack GATE with a top rank. No, my dear friends, that is not the case. Even you can do. Even you can do it. But yes, just you need to believe in yourself and visit this link. But remember, this is a case sensitive link, so write this in uppercase. Other than that, if you join plus subscription, you get all the top educators like me teaching you live in daily lectures, along with providing you daily practice paper, weekly quiz, test series, previous year question, practice question, crash course, rank improvement batch, and most importantly, clearing your each and every doubt. So if you join plus subscription, it is an entire world inside it. So you don't have to look outside. Once you enter plus, every need of yours will be taken care of, and we will make your journey as smooth as possible towards that destination of getting under 100, under 10 rank. Believe me, my friend, you leave that strategy part to us. You leave the content part to us. You just work hard and we will make sure that you obtain the top rank in GATE and ESE. And Iconic is a big brother of Plus. Yes, this is a little brother. So Iconic gives you everything that a Plus subscription gives, along with much more. The major part of Iconic is this personal coach, a person dedicated to you on a daily basis to get you the top rank, guiding you, getting your schedule design, making your strategy. Everything that you need to get the top rank is being done by this personal coach. He'll also create a study planner for you, which you can follow blindly and reach your destination with utmost ease. They will be analyzing your test result and tell you where you are lacking, how you can improve. So that way, my dear friend, everybody else will get a standard analysis, but you will get an analysis just tailor-made for you. Along with it, we have included study material additionally, theory and question bank, and soon we'll be introducing interview guidance into this. So this will become a complete package for a student who wants to take that journey from being an average student to sitting into a PSU or a MTech seat. So for them, this journey will be just like driving a Lamborghini to work. So that sort of a experience, that sort of a royal experience we are going to give you. So let's move on to the lecture, and if you want to join Unacademy, just make sure you use the code Ankit ESE to get my guidance as well as to get 10% over and above whatever Unacademy offers you. So now let's move on to the lecture, dear friends, and let's see what we have in store for you.
Hi guys, in this video we will see problems based on biasing of BJT and one application that we have seen with BJT, that is the voltage regulator. Okay. So we'll use the basic concept behind biasing, that first we'll assume the active region, we'll find the currents and the voltages, and then we'll check whether our assumption was correct or not. So let us start with the first problem. It is asking us the collector base and the emitter current for the silicon transistor, and the data that it is giving us, VCE sat is 0.2 volt. This should be VBE active. Okay, this will be VBE active 0.7 volt, VBE sat 0.8, beta equal to 100. And RB has two values in the first part, 200 kilo ohm, in the second one 50 kilo ohm. So let me solve first part here. So I'll assume active region. So the first thing that I'll do is I'll assume active region of operation. In that case, this voltage I will take 0.7 volt. Okay, and I'll apply KVL in this loop. If I apply KVL, what I'll do is 5 minus IBRB minus 0.7 equal to 0. From here I get IB as 4.3 over RB, that is 200 kilo ohm. So it will be 0.215. Okay, sorry, 21.5 actually, 21.5 microampere. Okay, so that base current we'll get. Since we have assumed active region, the collector current will be beta IB, that is 100 IB, or you can say 2.15 milliampere. Now we have to find out the collector to emitter voltage in order to check our assumption about active region. So if you wish to find out VCE, what you will write? 10 minus 3 IC. Okay, that is 10 minus the voltage drop across this resistance. So 10 minus 3 into 2.15, that is 6.45. So that will come out to be 3.55 volt. Okay. Now this VCE is greater than 0.2 volt, which means it is active region of operation. So our assumption was correct. But we also want to find out emitter current, which is collector current plus base current. So 2.15 plus 0.0215, 2.1715 milliampere. So that will be the emitter current. Okay, so that is how you have to try such kind of problems. Let us see the second part. In the second part, it is asking us the same currents, but now RB has become 50 kilo ohm. Okay, again I'll assume active region. So this voltage will be 0.7. Now I will apply KVL in the input loop. So 5 minus IBRB minus 0.7 equal to 0. Now I'll say IB is 4.3 by 50 kilo ohm. So that will become how much? If I multiply it by 2, it will become 100. So 8.6, 86 microampere. Okay. This is a simple calculation. What I have done is I have multiplied and divided by 2 so that it becomes 100 and then I can easily calculate the current. Now IC is simply beta IB again. I am assuming active region. So 100 IB. So this IC comes out to be 8.6 milliampere. Now we have to again calculate the value of VCE. VCE would be 10 minus 3 IC. 10 minus 3 into 3 into 8.6, it will become 25.8, which is less than 0.2 volt. Means our assumption was incorrect. This is the case of saturation region. Now in saturation region, what we have to do is, we have to take VB 0.8 as given in the question, and this VCE will now be 0.2. So now I will apply KVL in the input loop again. 5 minus IBRB minus 0.8 equal to 0, which implies IB is 4.2 by 50 kilo ohm, 84 micro ampere. Now I will apply KVL in the output loop. 10 minus 3 IC minus 0.2 equal to 0. So IC is 9.8 by 3, that is 3.266 milliampere. Remember, now you can't write IC equal to beta IB because it is not active region. So how do we find out IE? IE is simply IC plus IB, 3.266 plus 0.084. So it will come 3.35 milliampere. Okay. So the answer would be 3.35 milliampere. Now, in the next question, again it is asking us collector current, base current and emitter current, and beta is given as 100, VCC is 10 volt. But now the difference is that here there is a emitter resistance. So again what I'll do is, I'll start by assuming active region. So I'll take this as 0.7. Now I'll apply KVL in the input loop. So I'll write 5 minus 200 IB minus 0.7 minus 2 IE. Now since we have assumed active region, I can write down IE is 1 plus beta IB, that is 101 IV. If I substitute it here, it will become 202 IB. So IB will come out to be 4.3 by 402. Okay. So if IB is coming out to be 4.3 by 402, what will be its value? It will come out to be 10.6 microampere. Okay, you can substitute this value in the calculator. Now I can write down IC is beta IB, which means 1.06 milliampere. Okay, and IE is IC plus IB, 1.06 plus 0.01, 1.07 milliampere. But we have to check our assumption by finding out the value of VCE. So by KVL, I'll apply KVL like this. By KVL, I'll write VCE is VCC minus ICRC minus IERE. Means total voltage minus the voltage drop across the two resistors. 1.06 into 3, 1.07 into 2. So 10 minus 3.18 minus 2.14 means 5.32. So it will become 4.68, which is greater than 0.2 volt, which means our assumption is correct. So we have correctly assumed the active region of operation. Next question, we have to find out the collector voltage VC in the circuit, and it is saying assume silicon transistor. Silicon transistor means VB is taken as 0.7 volt and VC in saturation is taken as 0.2 volt. Beta is given as 75. Okay. Now what you have to do? The current here is IB. The current here is IC. So the current here is IC plus IB. The current here is by KCL IE, which is IC plus IB. And which type of biasing is it? It is collector to base bias. Now what I will do is, I will apply KVL in this manner. Okay, like this. So what KVL equation will I write? I will write 5 minus 10 times IC plus IB minus 20 IB minus 0.7 minus 2 times IC plus IB. Now since we have assumed active region, IC will be taken as 75 IB. So 5 minus 10 IB plus 20 IB plus 2 IB, 32 IB minus 0.7, 10 IC and 2 IC, 12 IC, IC is 75 IB. So IB will be 4.3 by 32 plus 900. So how much will this come out to be? This will come out to be 4.6 microampere. Okay. So it will be 4.6 microampere. Now from this, if we calculate IC, or let us calculate IE, 1 plus beta IB. So this IE will come out to be how much? 76 into 4.6 microampere. Okay. Now how to find this VC? This VC will be 5 minus 10 IE. So this voltage will come out to be 1.504 volt. Okay. But then again we have to check whether our assumption about the active region is correct or not. Okay. For that we need VC, which is VC minus VE. VC is 1.504. What about VE? VE will be IE into 2. So this will come out to be 0.8, which is greater than 0.2. Hence our assumption about active region was correct and our answer is correct. Remember, whenever you face the question based on biasing, always remember to check whether or not the transistor is in active region. Moving on. In the next question it says, for silicon transistor, assume beta is very large. We have to find RL, R1 and R2. Now see this thing, what I have told you. First of all, for DC analysis, what we do is, we open circuit capacitor and short circuit inductor. For AC analysis, we short circuit capacitor and we open circuit inductor. Okay. So that means if we are doing DC analysis, this capacitor would be open circuit. Why? Because 1 by omega C would be infinite. Now whenever you see this thing, beta is very large. If beta tends to infinity, IB, which is equal to IC upon beta, tends to 0, due to which ammeter current is approximately equal to collector current. Okay. So whenever beta is large, always ignore the base current and collector and ammeter current would be same. Now see this question. Here this collector current is given as 1 milliampere. Just now I have told you beta is large, so collector and ammeter current are same. This will also be 1 milliampere. And again this will also be 1 milliampere. Okay. Now, since the base current is 0, these three resistances are in series. So that much I have understood about this circuit based on the language given in the question. Now it is asking me the three resistances RL, R1 and R2. So to find RL is very simple. Just apply KVL across RL. 9 minus 6 by 1 milliampere, 3 kilo ohm. Okay. Now what about R1 and R2? For that, what we can do is, we know this voltage 3. So this voltage will be 3.7. Now, what about this voltage? If I call it as V, V is 1 milliampere into 200 ohm, or you can say 0.2 kilo ohm. 0.2 volt. So what will be the base voltage? You will add 0.7, 0.9 volt. Okay. We know now it is 0.9. So we can find out this current. Suppose this current is I. I will be 0.9 divided by 18, which will now become how much? 0.05 milliampere. Okay. Now since R1, R2 and R3 are in series, this current is also I and this current is also I. Now apply KVL across R2. R2 will be 3.7 minus 0.9 by 0.05. 2.8 by 0.05 means 2.8 into 20. 2.8 into 20 is how much? 56 kilo ohm. Similarly, apply KVL across R1. It will be 9 minus 3.7 by I, which means 5.3 into 20, 106 kilo ohm. Okay. So it will come out to be 106 kilo ohm and 56 kilo ohm, and the load resistance is 3 kilo ohm. Is it fine? So remember, whenever you see that beta is large, always ignore the base current and assume collector and ammeter current to be equal. Next question. For silicon transistor, find the value of R1. We are given VBE, IE and alpha. Now what is alpha? Alpha is IC over IE, which is given as 0.98. Okay. So this is a problem which is based on alpha and not on beta. Generally we get the value of beta. So now this voltage is VBE is 0.7. We know the value of IE as 2 milliampere. Now based on this value, can I estimate the value of ammeter voltage? Yes, I can, by applying KVL. 2 milliampere into 100 ohm, that is 0.2 volt. Now as soon as I get the ammeter voltage, can I estimate base voltage? Yes, we can estimate base voltage. 0.2 plus 0.7 is 0.9 volt. Now once we have base voltage, what else can we do? We can find out this current I. So I will be 0.9 by 20 means 0.045 milliampere. Now if I want base current, we know that alpha is collector upon ammeter current. From this I can say collector current is 1.96 milliampere. So what is base current? Ammeter current minus collector current. 2 milliampere minus 1.96 milliampere, that is 0.04 milliampere. If I have IB also, I can find out this current I1. I1 is how much? I plus IB 0.085 milliampere. See, when I am solving this question, I am not thinking about anything. I am just proceeding step by step based on what values I am obtaining. Now it is asking R1. I know the current in R1. But what I need? I need the voltage in R1. This is IC. So I will call this current as I2. What is I2 by KCL? I1 plus IC 0.85 plus 0.085 plus 1.96. Okay. So 2.045 milliampere. Now this voltage we know base voltage is 0.9. So how can I calculate R1? By applying KVL. So what I'll say, 12 minus 3.3 I2 minus I1 R1 equal to 0.9. So R1 will be 12 minus 0.9 minus 3.3 I2 over I1. So this R1 will come out to be how much? It will come out to be 51.2 kilo ohm. Okay. So that will be the value of R1. So what I have done actually is I have estimated ammeter voltage using the ammeter current, and then I go on estimating the currents and the voltages at different nodes inside the circuit. And once I get all the currents and voltages, then question is simply based on KVL. Okay. So that becomes very easy for me. Next question. For a silicon transistor, find the value of R. Again it is saying silicon transistor. What it means by that? That VB is 0.7 volt and VC saturation is 0.2 volt. Okay. Now I don't know anything about this question. Let us see how we can try. It is asking us the value of R. So first I'll mark the currents. This current is the base current IB. This current is the collector current IC. This is ammeter current, which is IC plus IB. By KCL, this current is also IC plus IB. Now see this, one data that it has given us is VC is 5 volt. Now once we know this data, what I can do is I can apply KVL like this. So how you will write KVL? 24 minus 10 times IC plus IB can be written as IE. This is also equal to IE minus 5 minus. Always remember I am taking all resistances in kilo ohm, so I will write it as 0.27 kilo ohm. 0.27 IE equal to 0. So this IE would be 19 by 10.27. So if IE is 19 by 10.27, how much will this come out to be? It will, let us leave it like this. I'll write milliampere. Now what we need is the resistance R. For resistance R, what you do is you apply KVL like this. What you can do is, if we apply KVL, you take this 0.7, then apply KVL like this. Okay, like this. So what I'll write is now 24 minus 10 IE minus IB into R minus 0.7 minus 0.27 IE. Okay. So now 24 minus 10 IE minus 0.27 IE equal to IBR plus 0.7. Now see this data. 24 minus 10 IE minus 0.27 IE. How much will it become? 5. So how you will calculate R? 5 minus 0.7 by IB. IB can be written as IE over 1 plus beta. So 4.3 into beta is 45, 1 plus beta is 46. So this R comes out to be 107 kilo. Now how I have assumed active region? See, VC is 5 volt, it is greater than 0.2 volt, which means the device is by default in the active region. And if the device is in active region, I can directly use IE equal to 1 plus beta IB. Next question. For a silicon transistor, find the mode of operation and the value of collector current IC. Now if it is asking us the mode of operation, how we will start? We will start from active region. So VBE will be taken as 0.7. So this current is IE, this current is IC. So I'll apply KVL in this loop. So what I'll write? 2 minus 0.7 minus IE equal to 0, which means IE is 1.3 milliampere. Okay, this is actually IE into 1 kilo ohm, not simply IE. Now it is saying beta is large. Whenever you see beta is large, what thing should come to your mind? IE equal to IC 1.3 milliampere. But then we have to check for active or saturation region, for which I will calculate VC. VC will be 10 minus 10 IC, which is minus 3 volt, and VE is 2 minus 0.7, 1.3 volt. So VCE is how much? Minus 3 minus 1.3 minus 4.3, which is less than 0.2. So our assumption about active region is incorrect. The region will be saturation. Now how to solve for saturation? We will take VC equal to 0.2 and I'll apply KVL now in this loop. Due to large beta, I can say IC and IE are same. So KVL will be 10 minus 10 IC minus 0.2 minus 10 IE equal to 0. So 10 minus 0.2 is 20 IC. So IC is 9.8 by 20, 0.49 milliampere. Okay. So this we have derived based on saturation. Again we started with the very same point, that is by solving or by assuming active region and then deriving the current. Otherwise, if you want to do it more accurately, one thing what you can do is, if you want more accurate solution, okay, this is not entirely accurate. One thing what we can do is, see, for saturation it is giving us 0.8 volt, 0.8. So if I apply KVL in this loop, in the inner loop which I was applying earlier, I will write 2 minus 0.8 minus IE into 1 equal to 0. So IE will be how much? IE will be equal to 1.2 milliampere. Now when you are calculating IC, then in that case don't assume IE and IC to be equal. What you will do now? 10 minus 10 IC minus 0.2 minus 10 IE equal to 0. So 10 minus, how much we will write? 10 IC, okay, minus 0.2 minus 10 into IE is how much? 1.2 equal to 0. So IC is, okay, so IC will how much? 10 minus 1.4, that is 8.6 by 10, 0.86 milliampere. So that will be the correct answer. This will be incorrect. Okay, are you getting my point? Why this answer is incorrect? Here I directly assume that IC equal to IE, but if you can calculate IE, you have to calculate IE separately. Don't assume them to be equal even if beta is large. Okay, because that beta is only useful in active region, and since we are operating in saturation region, we will not use the value of beta. So you have to calculate IC and IE separately. Okay, so we'll move on to our next problem. In the next problem, it says for a BJT, VBE active is 0.7, VBE saturation is 0.8, VCE saturation 0.2, beta equal to infinity. Now it says that the switch opens at t equal to 0. Find the time at which transistor leaves the active region. So let us see initially. I will say at t equal to 0 minus, switch is closed. If the switch is closed, this VC becomes grounded. The collector voltage is 0. What about emitter voltage? Emitter voltage is minus 5.7. So what about VC? 0 minus 5.7, that is greater than 0.2. Active region. Okay. Now what happens? When you switch off, when you turn off this switch, current will start flowing into the capacitor. If current goes into the capacitor, this IC is capacitor current, not collector current. If current goes into this capacitor, then this capacitor will start to charge. If this capacitor starts charging, then VC starts to increase. If VC starts to increase, then what can happen is that transistor can enter saturation region. So let me show you how. First I will calculate emitter current IE. So how to calculate emitter current? Minus 5.7 minus 10 by 1. That is 4.3 milliampere. Now we know since beta tends to infinity, IC will also be approximately 4.3 milliampere. Okay, or I say IC, not ICU actually. Let me say IC and I will call this current I. So this collector current IC is 4.3 milliampere. Then what about I? I will be 0.5 milliampere minus 4.3 milliampere. That is minus 3.8 milliampere. Minus means that the current is going upwards. If current is going upwards, the lower terminal is positive and the upper terminal is negative. So what I'll say? C dVc by dt equal to I. Okay. Now VC is this voltage. VC is this voltage. Now for saturation region, what happens? VCE must be 0.2, which is VC minus VE. VE is minus 5.7. So VE is minus 5.7. So VC must be minus 5.5 volt. From here I will say dVc is minus I by C dt. VC is initially 0, time is 0. At time t, VC must be minus 5.5 so that transistor enters saturation region. Are you getting my point? So on the left hand side I will write minus 5.5, I is minus 3.8, C is 5 microfarad and time t. So this t will be 5.5 into 5 by 3.8. IC is how much? 4.3 milliampere. This I is 0.5. 0.5 minus 4.3 is 3.8. Okay. So 5.5 into 5 will be how much? 27.5 by 3.8. 275 by 38. 38 5 190. 38 6 will be 228. 38 7 236 266. So it will be 797.2 microsecond. Okay, sorry, millisecond. Is it fine? So that is how we can calculate the value of time at which our device will saturate. Okay, so that will be the answer. So let us see the next problem. It says the silicon transistor used in the circuit below has beta equal to 30 and negligible ICBO. We need to find collector current. So if ICBO is negligible, I can say IC is beta IB. So unless this ICBO is given, you will always neglect this ICBO. It is silicon transistor, so this voltage will be 0.7. This voltage due to Zener diode will be 5 volt. And due to this diode, it will be a drop of 0.7. So let us apply KVL in this loop. Okay, this is your base current IB. 5 minus IB into 1 minus 0.7 minus 0.7 equal to 0. So IB will come out to be how much? 3.6 milliampere. Now once we have got IB, we can say that IC will be beta IB. If it is beta IB, 30 into 3.6, that is 108 milliampere. Now if you calculate VCE, so VE is how much? Minus 12. You have to find out VC. VC will be 0 minus 2.2 into IC. So that is 216 and 21.6, that is 237.6. So that means VCE will be minus 237.6 minus 12 minus 225.6, which is less than 0.2. So our assumption is incorrect about active region. This transistor is in saturation. For saturation, what we will do is we will take VC equal to 0.2. So now VC will be minus 12 plus 0.2, that is minus 11.8 volt. So what about this collector current IC? IC will be 0 minus 11.8 by 2.2, means 118 by 22, that will be 5, 110, 80, 66, 145.36 milliampere. Okay, so that will be the collector current, 5.36 milliampere, and this transistor is operating in saturation region. So again I have used the same technique. I have assumed active region and then found out VCE. Moving on to the last problem, it is asking the power dissipation across the transistor. Now this is an example of a voltage regulator circuit. Okay. Now in this circuit, Zener voltage is constant at 0.6 volt. Now always remember, for transistor we will take VBE equal to 0.7 volt. Okay. Now here we have voltage 15 volt unregulated. Now as I told you, in an op-amp what we have to do? In an op-amp we will apply virtual ground in case of negative feedback. How negative feedback? This is the feedback voltage applied to the negative terminal. Okay. So virtual ground means the positive and negative terminal voltages must be same. So that means this negative terminal voltage should be how much? It should be 6 volt. Which means this feedback voltage is 6 volt. One more thing that I told you about op-amp, there is no input current to the op-amp. So these two transistors are in series. If they are in series, I can apply voltage division. So VF is output voltage into 24 by 24 plus 12. So that means V out is 6 into 36 by 24. So that is 9 volt. So we get the output voltage as 9 volt. Now we know how to find power dissipation in a transistor. It is VCE into IC. Since beta is large, I can say that IC is approximately IE. So this will be VCE into IE. Now VCE can be written as 15 minus 9, that is 6 volt, 6 IE. So I need this ammeter current. Ammeter current is sum of two currents going into the load resistance and this 12 kilo ohm. So this is 6. The current in 12 kilo ohm is 9 minus 6 by 12. Current in 10 kilo ohm is 9 minus 0 by 10. So 3 by 12 is 0.25 plus 0.9 means 1.15. 1.15 into 6 will become 6.9. Is it milliwatt or watt? It is milliwatt. So 6.9 milliwatt is the power dissipation in the BJT. So remember, when it is asking power dissipation in BJT, you have to solve VCE into IC, and when we are solving VCE into IC, we have to find two parameters, VCE and IC. So I have found out VCE as the collector emitter voltage across transistor, and IC will be equal to IE because beta is large. Okay. So that will be all from this lecture. In the next video, we will see one more application of DC analysis of BJT, which is current mirror. So that will be covered in the next video. Thank you.
I hope all of you have enjoyed the lecture that we were providing, and all of you learned something very good. Now is the time to learn about the Unacademy subscription. So as I told the benefits of the Plus subscription at the very beginning, let's go through them very quickly. Live classes you get by the top educators, crash course, rank improvement batch, doubt clearing, weekly quiz, test series, previous year question, practice question, everything in one subscription called as Unacademy Plus. And iconic is one level higher. It provides you a personal coach who will mentor you on a daily basis, who will guide you on a daily basis, along with providing you study planner, test analysis, study material, and soon enough interview guidance. So if you are looking to join Unacademy, let's see what are the pricing. So my dear friends, before we see the pricing, just see the link. This link will help you crack GATE and ESE with the top rank, because we have created the first ever video book for GATE and ESE for my YouTube family, and you will get the notes as well as the lectures here. Just make sure that you write this link in the uppercase, and you will get to the first ever video book for GATE and ESE, and it is nothing but revolutionary. Now let's see the pricing of Plus subscription. So for 12 months the pricing is 3250, but if you apply the code Ankit ESE, it becomes 27225. For 18 months it will be 34650, and for 24 months 39600. Believe me my dear friend, this is the most affordable pricing, and the longer duration subscriptions are more cost effective as compared to shorter duration. Like here it will cost you 1650 per month. Okay, this will be 2000 per month approx. This will be around 2250 per month. Then if you go for iconic for 12 months, it is 5250. With code Ankit ESE it becomes 45225, and 2-year subscription becomes 66600. So the choice is yours, but take a longer duration subscription for more cost effective solution, and to give GATE and ESE at least 2 times, so that if you once crack GATE, in the next attempt you can even get ESE. And other than that my friends, you can download the Unacademy learning app right now, because there we provide live classes for free, test series and live quizzes for free. And once you download it, make sure that you follow this profile. This is my profile, so that whenever I come live, you will get the notification. And this is the Telegram channel for our team. Here you will find all the lecture links, all the lecture files, and all the links for the special classes. Other than that my friend, my personal Telegram channel also you can join, t.me/GateAIR1. Here you can get in touch with me, and we can take this journey together. Okay. Other than that, we have other YouTube channels like Mechanical, Civil and Telugu, JE channel, Computer Science, Gate Question and Electrical Junction, Pathshala and GS Terminal. Electrical Junction contains short videos of great concepts. Pathshala provides you animated content. JE preparation can be done through these 2 channels, Unacademy SSC JE and GS Terminal. And you can refer the other channels to the other friends in respective branches, so that they can also be benefited. At last, I would like to say, please share, like and subscribe to this channel. Subscribe to this channel, and not only subscribe, press the bell icon so that you get notified whenever a new video comes. And share these videos among all your college group, among all your friends, so that we can create the first ever revolution of free education in field of GATE and ESE. Thank you to everybody for dedicating time to watching this video. Please move on to the next one as well and take the benefit of all the free content that we are providing. And in case you have completed the series, do make sure you watch the other subjects available on this channel. Thank you.